So joint, it happens sometimes, joint marginal and conditional distributions for continuous variables. So we had looked at this joint distributions of discrete variables, and the continuous variables behave pretty much the same way, except that in this case we are dealing with probability density functions. So suppose we have two variables x and y, their bivariate PDF is going to be fxy. What will be the bivariate CDF? Bivariate PDF, which is given by S and say ST, will be given by P. X is less than S and Y is less than or equal to T, which you can do by adding up all the probabilities before S. So this is going to be negative infinity to T and double integral and negative infinity to S fxy dx and dy. So this is how you can get the bivariate CDF. Now this is a double integral, of course, and then there is the marginal distribution. So then you calculate the marginal distribution. Marginal distribution is also just like this. You can calculate marginal distribution of x or y. If you want to do marginal distribution of x given y for all the values of y, this is for all the values of y, it is going to be infinity fxy dy. Instead of summing, you are just taking the integrals. So if you are doing marginal distribution of x, the limits is going to be of y. These limits are going to be of y because we are summing for all the values of y. So this will be the marginal distribution of x. Marginal distribution of y similarly is going to be minus infinity to plus infinity fxy dx, and here you are going to have the limits of x. So this thing is the marginal density of x because here is a dy here, and these are the limits of y, and this is a marginal distribution of y because we have a dx here. Then so we can do other things also, like expected value. So expected value of xy is again going to be negative infinity to infinity, negative infinity to infinity, xy, this is exactly how we do it, x and y, dx and dy. So this is how you can get the expected value. Then you can also do the conditional distributions. So we have conditional distribution. Conditional distribution PDF of y given x is equal to x. So this is g of y given x will be described by fxy divided by the minus infinity to infinity fxy dy. So what is this? This is the bivariate PDF, and this thing here is the marginal PDF of x. So bivariate PDF conditional distribution of y given x, y given x, you would put the marginal distribution of x, and then the other thing is the expected value of y given x is equal to x is just going to be negative infinity to infinity y, and now you're gonna put g, this thing here, gy given x here, and you put the y, and you're gonna put dy. This is how you will calculate the expected value of y given f. Now we're gonna do some questions. So first question is that the joint PDF of x and y are f xy is equal to 3 by 8 y square plus 2xy, and the limits of x is between 0 and 2, and limits of y is between 1 and 0. We want to know the marginal PDF of x. So again, we want to know the marginal PDF of x, which is this number right here, which is going to be, and we are doing the marginal PDF of x, so we're going to use the limits of y, which is 0 and 1, and we're going to do fxy, and we're going to do y because we're doing marginal PDF of y x, so we're going to do dy, and then we're going to solve this using integration, and we get to this number 1 by 8 1 plus 3x.